What's up, everybody? This is Chase Crump, and today I'm going to be talking about box fill and how to size your box. So, first thing we got to know when you're doing these box fill calculations or trying to find a box that you can use for the wires that you have is actually know the size of wires that you have. So, as we can see, this is all 14 gauge Romex. So we just know that that's our starting point, basically. It's up to 14 gauge. That'll come back into play here in a minute. But for right now, we just know that there's 14 gauge going in here, and we have two switches. So we need to look at Article 314.16 B 1 through 5. And that's going to give us everything that's counted within box fill. And that's actually things that are inside the box, they're internal, not external. So our conductor fill is 314.16B1, and your conductor fill is basically all your conductors. So this here, I don't know if you can tell, that actually has 4 wires in it, but there's only 3 that are conductive. So you have 2 hot wires, the black and the red, and then your neutral is normally your white. And we'll get back to that little 4th wire here in a minute. So in this specific box, our conductors, we're going to need to count up our conductors. So we have 1 3-wire and 4 2-wires. So we'll count up each of the 2 wires. 2, 4, 6, and then 8 for that one. And we add 3 for this 3-wire because there's 3 conductors in there. So it gives us an 11. There's 11 conductors we're counting for in there right now. So next thing you need to think about is 314.16B2, and that's clamp fill. So I know a lot of people might think that these are clamps, which they are, but they're not internal clamps. So we just have to worry about if there's anything on the inside that's holding our wires down, it's taking up space on the inside of that box. And in this case, we don't have anything. So we just go on to the next thing. 314.16B3 is support fittings. And that's like your fixture hickeys and stuff that's actually supporting weight. And those little hickeys or whatever, they take up space inside that box, so you'd have to account for them. But in this case, again, we don't have anything to worry about there. 314.16B4 is our device fill, device and equipment fill. So that says for devices that take up, they take 2 screws to screw in, basically. So there's a double allowance that you have to count for on all your devices, whether it be a switch like we have here, or if it's a plug. Everything you're going to screw in has, 2 holes for that to be screwed into, one here and one here. So in 314.16B4, it says that each device that you're counting for in your box as a double allowance, and that's because you have 2 yokes, so single and double, so you're counting both of those. And then the way you count them is based on what size wires are hooked up to it. So in this case, we know we have 14 gauge hooked up to it. So again, we'll get to calculating here in just a second. But so we had 11 conductors right? So 2, 4, 6, 8, 11 conductors. So there's one more thing we have to think about, and that is our equipment grounding conductor. So in 314.16b5, it tells us about our equipment grounding conductor, and that it all counts as one. This is actually changed in the new code, in the 2020 code. But in this case, we're just going to roll on with the 2017 because that's what we have. That's what's accepted in Kentucky right now, so we're just going to stick with that. So our equipment grounding conductor, there's an equipment grounding conductor in each one of these Romex cables, but even though there's 5 of them, we're only going to count as one. So that's one at the larger size ground that you have in there. So again, this is all 14 gauge, really simple. And so we'll just add one more onto our original 11 conductors. So we're going to tie it all together right now. So we had 11 conductors, 1 equipment ground, and 4 yokes, or little screw holes, basically, that we're counting for our devices. So there's a total of 16 things that we're accounting for. 12 wires, including the ground, and then 4 yokes. So 16. And if we go to table 314.16b, we can see our multiplier for 14 gauge for cubic inch. So 14 gauge, the multiplier is 2. So what you do with that is actually you're gonna multiply all that by 2, but we'll show it on paper here. So if we have 12 wires, including the ground, right? 11 conductors, 1 ground. They're all 14 gauge, so we know our multiplier for 14 gauge was 2 off that table. So 12 times 2, the multiplier for 14 gauge, is 24. And we have 2 devices connected to 14 gauge wire. And those devices, like we said, are double volume allowance. So 2 times, basically 2 times 4, but your 2 is not coming from the 2 devices, it's coming from the multiplier for 14 gauge. So there's 2 double allowance devices, so this is really 4. So 2 times 4 anyway is 8 cubic inch. 24 cubic inch plus 8 cubic inch is 32 cubic inch. So now what we have to do, now that we know that what we need in this box, or what we actually have in this box, is 32 cubic inches that we need to find a box to put it all in. So what you do with your 32 cubic inch, you come to table 314.16a, and right here in this column right here, actually is in cubic inch, is what we're going for. And you can basically use this table to pick and choose whatever device you want, really, or whatever box you want to use. So there's ways to take like these masonry boxes, and you could take 2 of them, put them together. 14 times 2 would be 28, which is not what we need. We need it up to 32. So what I went for was the 4-inch square by 2 1/8 inches deep. So that gave me a cubic inch volume of 30.3. Now I know that our original, what we came up with that we need to be able to put in the box is 32 inches cubed. So there's another little thing we can do about that. if you look at this box here, we actually used a plaster ring, mud ring, extension ring, whatever you want to call it, and it just bolts right to your 4-inch square. And if you see, it's a little bit wider than it used to be. So this particular mud ring here gives us an extra 6.3 cubic inches that we can add on to our 30.3 right here for the box that we chose. So we take that 30.3, we'll take that 30.3 for our actual box volume of the box we chose, plus the cubic inch value of the extension ring, which is 6.3. We add those together, and it comes up to 36.3 inches cubed. So now we know that we're good for our 32 inches cubed that we needed, that we know we have to account for. It has to be at least 32 inches cubed, and you can't be any below that. So we know we're good. Another thing that I will want to talk about is actually sizing the pool box. So what we have here, it's a little bit bigger box. It was an old panel. I just ripped the guts out of this thing, and I put some pipes here on the sides of it. And so in 314.28A1, it talks about straight pulls of wire in a pull box. So this will be our straight pull right here. And just to clarify a little bit, 314.28A1 is actually for wires that are larger than 4 gauge. So don't pay any attention to the wire size in this case, but that was just like a little visual thing I could do to actually get some wires in there to show that this is a straight pull. So 314.28A1 says that for straight pulls, your length and width of the box is actually based on your sizes of the pipe. So 314.28A1 says that your box has to be at least 8 times the trade size of the biggest trade size pipe that you have on each side. So from left to right, we're just going from 1 inch to 1 inch, and then you do right to left, which is still 1 inch, 1 inch, so we're not going to worry about it. So 8 times 1 for this, because this is a 1 inch pipe, is 8 inches. And then it'd be the same thing over here, 8 inches. So for us to have a straight pull of wire, 4 gauge or larger, and 1 inch to 1 inch, you have to have at least an 8 by 8 inch box. Another thing that it talks about in 314.28 is the angle or U-pulls of wires 4 gauge or larger. So that'd be an angle. You can obviously tell this is an angle. There's an angle in this wire. So 314.28A2 says that angle pulls are 7 times the largest pipe. So on straight pulls we did 8 times the biggest pipe. On angle pulls we do 7. And it also says we have to calculate both sides of the angle. So we have to calculate for this side, wherever the wire's going from. So there could be, more pipes over here, but we're only worrying about what sides that this wire is actually traveling through. So what it says is it's 7 times the biggest pipe. So we go 7 times 1, and then it says we have to add the rest of our pipes to that 7 times whatever the largest pipe you have. So in this case, 7 times 1 plus a 3/4 plus a 3/4 plus a 1, another 1 inch. That is 2.5. So we had 7 plus 1.5 is 8.5 plus 1 is 9.5. So that is our actual inch value that we have calculated for this side. So now we come down here and we have another 1 inch and then 3 3/4 inch pipes. So we would do our 1 times 7 again, which is 7, plus 0.75, 0.75, and 0.75, which is 2.25. So we do 7 times 1, 7, plus 2.25 is 9.25. So now we know that for this side down here, we have to have at least a 9.25 inch, 9 1/4 inch length to the side. But what that code article actually says is that you're going to use the larger of the two calculations. So we did come up with 9.5 on this side and 9.25 on this side. So we're going to use the larger, and that's going to be our total dimension of the whole thing. So it'll be 9.5 inches by 9.5 inches to actually size that box. So I hope I made some pretty good sense out of that. Hope I maybe even cleared up some of that for you all. So this has been Chase Crump on Boxville, and then pull box and junction box sizing for wires over 4 gauge. Thanks.